In this video, we're going to look at how to solve a system of linear equations with three variables. When you do this, you want to start by combining two of the three equations in such a way that one of the variables cancel. So when I do these, the first thing I look at is which variable do I want to eliminate, because I have to eliminate the same variable from all three equations. And in this one, I'm going to select the y values. The reason I'm selecting the y values is because, well, if I combine these two, the y's already cancel. Positive 2 and negative 2 add to 0. And if I select these two, same thing. Negative 2, positive 2 cancel out. So I'm going to go ahead and take the first and the third. I'm going to rewrite them over here. Whoops, starting at the wrong spot. X minus 2y plus z equals negative 11, and negative x plus 2y plus 4z equals negative 9. When I combine these together, I get lucky and two of these cancel out, which leaves me with 5z equals negative 20, which means our z value is negative 4. The next thing I'm going to do, I have to use the second one, because I haven't used it yet, and one of the other two equations, and I must make sure that I cancel out the same variable. So if I select these two, I can't choose to eliminate the x values. I have to eliminate the y's, because I eliminated y's here. Although technically, because we got lucky and these canceled out, I guess we could eliminate x's if we chose. But I chose y's, so we're going to stick with y. So I'm going to rewrite these over here. And I'm combining that with 3x plus 2y minus z equals 7. And we get lucky on this one too, and these cancel out, which leaves me with 4x equals negative 4, which means our x value is negative 1. Once you have two of the equations, you're going to plug both of them in to one of your originals to solve for the third variable. So, pick an equation. Which one do we want to use to solve for y? Doesn't matter which you choose, just make sure you pick one of these. So I'm going to pick the middle one. 3x, well, plus 2y minus z equals negative 7. I'm positive 7. Where did I get negative from? Positive 7. Now I rewrote it over here so you would see which one I'm choosing, but I'm going to take these values and plug them in for x and z. So that's 3 times negative 1 plus 2y, which we don't know yet, minus negative 4 equals 7. So this gives me negative 3 plus 2y plus 4 equals 7. Combine my like terms, negative 3 and positive 4, and I get 1. Subtract 1 from both sides to get 2y equals 6, and divide to get 3. Now the solution to a system with three variables is written as an ordered triple. An ordered pair is an x followed by a y. An ordered triple is x, then the y, then the z. So I write my answer, in this case, as negative 1, 3, negative 4. Now this actually was a pretty short one. I know it might not seem that way, but it was a short one. Let me show you another example where it might take a little bit longer to solve. So let's take this 9x plus 2y plus 3z equals 170. 5x plus 4y plus 7z equals 173. And 4x plus y plus 6z equals 116.5. Now, when we do this, you always want to start by selecting which variable you're going to eliminate. Now, in this one, the y's would probably be the easiest to eliminate, because anytime you have a 1, it's easy to multiply that and cancel a number out. So if I wanted to combine the middle and the bottom one, I could easily multiply the bottom equation by a -4, which will cancel out the y's. But I'm going to not choose the y's. I'm going to show you how you might work it if maybe there weren't any easy ones. I'm going to choose this one. I'm going to choose to eliminate the z's, just to show you how you would go about working it if there wasn't an easily eliminated variable. So I'm going to start with these two. 9x plus 2y plus 3z equals 170, and 4x plus y plus 6z equals 116.5. Now, the first thing I'm going to do is multiply this equation by a -3. And the reason we do this is because when I'm sorry, -2. Sorry, had a moment. Multiply by -2, because when I multiply the 3 by a -2, I'm going to get -6, which when added to +6 cancels it out. So when I multiply everything by a -2, all four numbers, I'm going to get -18x minus 4y minus 6z equals -340, I believe. Let me double check myself. Yes. Sorry, I wanted to check after I made a small mistake here. I didn't trust myself anymore. Alright, so I'm going to combine that with the 4x plus y plus 6z equals 116.5. And when I add them together, my z's cancel. So -18 plus 4 is -14x. -4 and +1 give me -3y equals -223.5. So what I'm going to do now is I'm going to take the middle one, which I haven't touched yet, and combine that one with one of the other two. It doesn't matter, I can choose to combine it with the bottom one or the top one, but I have to use the middle one because I have not used it yet. So I'm going to choose these two. No particular reason, just because I didn't want to deal with another decimal. So when I do this, 9x plus 2y plus 3z, I'm just rewriting it, plus 4y plus 7z equals 173. Okay, I have to cancel out the z's in this equation because I canceled out the z's over here. If I choose a different one to cancel out, it's not going to work. So I have to cancel out the z's. So I need to multiply one, or in this case both equations, by a number so I get a positive and negative version of the same coefficient. So the smallest number I can think of that 3 and 7 both go into is 21. So I can multiply the top one by 7 and the bottom by -3, and I'll get positive 21 on the top, negative 21 on the bottom. So let me rewrite these. 9 times 7 is 63x plus 14y plus 21z equals 1190. Multiply everything on the bottom and I get -15x minus 12y minus 21z equals 173 times negative 3. I get negative 519. So add these two equations together and the z's will cancel out. So 63 minus 15 gives me 48x. 14 minus 12 gives me 2y. Z's canceled. So that equals 1190 minus 519, which is 671. Alright. Seems like we've done a lot. We're only about halfway done. Because now what we do, we have two variables with two equations. What you do now is you combine these two to eliminate another variable. So I'm going to choose to eliminate the y's because the numbers are smaller. You don't have to, you can choose x, but I'm choosing the y's in this one. So if I multiply this bottom, my one in orange, by 3, and this one by 2, I'm going to get negative 6 on this one and positive 6 on this one, so they'll cancel out. So for the one I did in green, multiplying everything by 2 gives me negative 28x minus 6y equals, one moment, that gives me negative 447. And then on this one, I'm going to multiply everything by 3. So that gives me 144x plus 6y equals 671 times 3 is 2013. So now I add these together and my y's cancel out. Combine these and I get 116x equals, let's see, 2013 minus 447 is 1,566. Divide that by 116 and I get 13.5 for my x value. Alright, seems like we've done a lot. We're not done yet. The next thing we have to do is we have to take the x value and plug it in to either of the two variable equations. It doesn't matter which one you pick, but you have to choose one of the two variable equations so you can solve for, in this case, y. So what I'm going to do now is I'm going to take the negative 14, that equation right there, and substitute in 13.5 for the x, and solve for y. So if I take 13.5 and multiply by negative 14, I'm going to get negative 189 minus 3y equals negative 223.5. What I'm going to do next is I'm going to add 189 to both sides. When I do this, I get negative 3y equals negative 34.5. And when I divide, I get a y value of 11.5. Whew, a lot of work. Still not done. Because the last thing we do is we take one of the three variable equations and plug in the x and the y to get the z value. So if I choose the 9x plus 2y plus 3z equals 170, I'm not going to rewrite that one. I'm going to replace the x with a 13.5. I'm going to replace the y with 11.5. I don't know z yet, equals 170. So first, I'm going to simplify the left side of the equation. this part right here, not the 3z part, this part right here gives me 144.5 plus 3z equals 170. When I subtract 144.5 from both sides, I get 3z is equal to 25.5. So when I divide by 3, I get 8.5 for my z value. So the solution to this system of equations, remember x, y, z, I have 13.5, 11.5, 8.5. And that is the answer to this system of equations. Now if you wanted to check yourself, you have to plug these numbers into all three equations. It has to be true for all three for it to be a valid answer. Now I will say that sometimes you can get equations where substitution is actually going to be easier than elimination. So one more of the three variable examples. Alright, so let's take x plus 3y equals 1, negative x plus y plus z equals 3, and x plus 3y minus 2z, make that look different, equals negative 7. Now the reason I say substitution might be easier is because this one is pretty easy to get into this form. So what I'm going to do now is I'm going to take the negative 3y plus 1 and plug it in for x here and get z by itself. So negative 3y plus 1 plus y plus z equals 3. Well, that's going to be positive 3y minus 1 plus y plus z equals 3. I'm going to add 1 to both sides, so it's equal to 4. I still have the z, and 3y and y give me 4y. So if I simplify this, I get 4y plus z equals 4. I can get z by itself by subtracting 4y from both sides. And now that I know x in terms of y and z in terms of y, I'm going to plug both of those into the third equation. So if I plug those into the third equation, x is negative 3y plus 1 plus 3y minus 2z, and I know z is negative 4 plus 4, negative 4y plus 4, I'm sorry, equals negative 7. So first thing I'm going to do is I'm going to distribute. Negative 3y plus 1 plus 3y minus, or plus, because negative 2 times negative 4 is positive 8y, and negative 2 times 4 is negative 8. Alright, so combining like terms. Negative 3y and positive 3y cancel out, leaving me with just 8y. 1 and negative 8 give me negative 7. If I add 7 to both sides, I get 8y equals 0, which means our y value is 0. So if I go back up here and plug in 0 for y, negative 3 times 0 plus 1 is just going to be 1. Negative 4 times 0 plus 4 is just going to be 4. So the solution to this system, x is 1, y is 0, 4 is my z value. So sometimes substitution is actually easier, but really it's only going to be easier if at least one of your equations has only maybe 1 or 2 variables, or it's well, this having at least one with only one or two variables is your minimum requirement. Any more than that is going to be more difficult to arrange. But sometimes substitution is easier compared to elimination. Alright, so that's all I'm going to do for the three variable systems algebraically. Next video I'll show you how to do them in what's called a matrix using a graphing calculator.